Trig integrals, part 3, using tangent and secant. Recall that sine squared x plus cosine squared x always equals 1. And if we were to divide every piece by cosine squared x, we would get tangent squared x plus 1 equals secant squared x. So tan and secant go together very well. More specifically, tangent squared and secant squared go together very well. Let's look at two different types of integrals that have tangent and secant in them. So what if we have tangent to the m of x times secant to the n of x, where m and n are both odd? An example would be tan cubed times secant to the fifth of x. When I see a situation like this, I usually think we will do a u substitution where u is secant of x. Let's see how this works out. If u is secant x, then du is secant x tan x dx. So I will pull one secant and one tan out of each piece and rewrite it as tangent squared times secant to the fourth of x times secant x tan x dx, which is my du. Now, if I were to go through and substitute my u's at this point, I would have tangent squared of x times u to the fourth times du. And the one piece left over I would need to fix is the tangent squared. Looking above at my Pythagorean identity right there, I notice that tangent squared equals secant squared x minus 1. But I already know that secant can be written as u. So I have u squared minus 1 times u to the fourth du. I would distribute the u to the fourth before I took the antiderivative, giving us u to the sixth minus u to the fourth du. Now we have some power rules to do. We get u to the seventh over 7 minus u to the fifth over 5, that is, plus c. And then we can back substitute u equals secant x, giving us secant to the seventh of x over 7 minus secant to the fifth of x over 5 plus c. So if I have tangent to a power times secant to the power, where both powers are odd, I think let u equal secant x. What if both powers are even? An example would be tangent to the fourth of x times secant to the fourth of x I would think u substitution again. But if the powers are both even, I think let u equal tan x. In this case, du would be secant squared x dx. Rewriting the integral, we would have u to the fourth times secant squared x times secant squared x dx. And I wrote that, or I at least thought about that, because I know this part here is my du. So I can write this as u to the fourth times secant squared x times du. From above, tangent squared x plus 1 equals secant squared x. And I want everything in terms of u's, so I want to turn my secant squared into tangent squared somehow, which I can using that identity, which gives us u to the fourth times tangent squared x plus 1 times du, and one more rewrite gives us u to the fourth times u squared plus 1 du. Now that we have everything in terms of u's, we can integrate, although I will rewrite the integrand one more time as u to the sixth plus u to the fourth du, which gives us u to the 7 over 7 plus u to the 5 over 5 plus c, and back substituting u equals tangent of x. We get tan to the 7th over 7 plus tangent of the 5th over 5 plus c. What if one was even and the other one was odd? Can you think of how to do this integral? Here, because I know that u equals tangent of x gives us du as secant squared x and that if I rewrote this as u times du, I would have a secant squared x left over. But as we know from above, that secant squared can be written as tan squared plus 1. And I will leave the rest of this up to you.